All right, let's go ahead and take a look at number 2. All right, now, for number 2, let's go ahead and take care of the restriction. Is there any restriction? What's the restriction? Huh?
-1.
-1 is actually fine if you take a look at it. If you square it, it becomes 1. So one way to quickly tell that there is actually no restriction in this case. Well, again, when do we have restriction is when the denominator becomes 0, right? And then if you look a little bit closer, well, x squared plus 1, right? X squared is always 0 or greater than 0. And that means it is actually no way for the denominator to be 0. There's actually no way for the denominator to be 0. So, so for the restrictions, we will simply say none. Okay. Again, before we go too far, ask yourself, do you know why we have restrictions? If you are not connecting to the idea of, oh, we don't want to divide by 0 because dividing by 0 will become undefined. If you cannot say it, that's a problem. All right, we have the same denominator. And again, I think we can just go ahead and add them all together. So the numerator is going to be 2x squared plus 2. The denominator is x squared plus 1. And can you see anything that we can factor?
2x squared.
Yeah, so the 2 can come out. So it becomes 2 times x squared plus 1. And guess what? X squared plus 1 is gone. So the final answer is 2. Okay. All right, so let's go ahead and take a look at example number 3. Okay. Example number 3. So again, for the restrictions, it's kind of hard to see restrictions when you are presenting, when you are presented with expressions like this. So guess what we're going to do? Well, they have the same denominator, right? Let's go ahead and do the subtraction right away. And I'm going to put a little warning right here. Why do I need this warning? Because it is a subtraction. And this is why you have to be, just be a tad more careful. So it's x squared plus 7x minus 6 minus 4x plus 2. Okay? Yes, because it's negative of the whole thing, right? You're subtracting the whole thing, so that becomes a plus 2. So that's why I want to use this very moment to make sure that everyone is warned. All right, the denominator. Now, actually, I see something in the denominator that the coefficients and the constants here are all multiples of 2. So I'm going to go ahead and, factor out the 2 or the 2's from those 3 terms. And then I'm going to simplify my numerator just a little bit. So x squared plus 3x minus 4. Yes. And 2 times, and I actually can factor this one out. X squared minus 4x plus 3, it's actually x minus 3 and x minus 1. The numerator could be further factored into x plus 4 and x minus 1. 2 times x minus 3, x minus 1. So what you can see here, similar to what we had yesterday, you factor, you simplify, and you get your final answer. Oh, you know what I forgot to do? I forgot to list out the restrictions. Yeah. So the restrictions are very important. The restrictions are what makes the denominator equal to 0, right? So that means x cannot be 3, and x cannot be 1. Okay, so should have done that after I factored, and that's also the reason why we should always factor.